All right, if you work with data, you know this feeling all too well. A dashboard is wrong, a report is late, and suddenly, all eyes are on you. Yep, data pipeline failures. They're one of the most common and, let's be honest, frustrating parts of our jobs. But what if I told you the real problem isn't that our pipelines fail? What if it's something way more subtle and a lot more dangerous? Let's unpack the real reason our data systems break and find a better way to build them. Just let that sink in for a second. The pipelines that cause the real, lasting damage aren't the ones that crash and burn with a big, loud error message. No way. The most dangerous ones are the silent ones, the ones that just keep on running, but quietly. Day after day, they're delivering data that's a little less accurate, a little less complete, or a little less on time. The problem just compounds and compounds until somebody finally questions a number, and by then, well, the damage is already done. And believe me, the damage is, wow, it's huge. A recent report from Fivetran found that pipeline downtime creates an average monthly business exposure of $3 million at large companies. This isn't just some techie engineering problem. This is a high-stakes business problem that touches everything from analytics to AI. So, to really get to the bottom of this, we've got to understand what we're actually up against. The folks at IBM call it the ghost in the machine. And it's that feeling we all get, right? That our pipelines have these fickle, unpredictable personalities. They seem to crash for no reason at all and spit out these maddeningly inconsistent results. But you know what? It's not magic. It's just complexity. This right here is where we need to completely redefine what we mean by failure. We're all familiar with the hard failures, a job that just stops, dead in its tracks. But the real danger, the thing we need to worry about, lies in the silent failures. These are the ones that corrupt our data without ever stopping the pipeline. They go completely undetected, slowly eroding trust and leading to terrible decisions based on data that nobody even realized was wrong. So how do we find these silent killers? Well, it all starts with learning to be a good doctor for our data systems. We absolutely have to learn how to tell the difference between the symptoms and the underlying disease. Because what we see on the surface, it's often just a tiny clue pointing to a much, much deeper issue. Okay, let's break this down, because this is really the core of it. A runtime error pops up. That's what we see. That's the proximal cause, the symptom. But the why, the actual bug in the code, that's the root cause. That's the disease. Or a job gets stuck in a queue. Symptom. The disease, you've run out of infrastructure resources. See, this distinction is absolutely key. If you only treat the symptoms, say by just restarting the job, you're basically guaranteeing the disease will come back. To really, truly fix it, you have to cure the root cause. This is where the best engineers separate themselves. They don't just hit restart. No, they play detective. They have a structured, repeatable process for digging all the way down to that root cause. It's not about guesswork. It's about having a clear method to follow every single time something goes sideways. And here's that detective's playbook broken down into 4 key steps. First, you analyze the logs. That's your crime scene. You have to pore over the evidence. Next, you identify the stage. Where exactly did this thing fail? Was it during ingestion, transformation, or writing to the destination? Then, and this is the crucial one, you have to reproduce the issue. Seriously, if you can't make it happen again on purpose, you don't really understand it. Only then do you apply and validate your fix, making sure it works not just in theory, but in the real world. So when you put on your detective hat, what are you actually looking for? Well, the good news is that most failures aren't these crazy, unique snowflakes. They tend to fall into a few very predictable categories. These are the usual suspects you're going to encounter time and time again. And here they are. Schema changes from upstream systems. Oh, that's a huge one. An API you depend on suddenly adds a new field or changes a data type. Bam! Then you've got data delivery misses from external partners. Classic code bugs, of course. Resource exhaustion, like running out of memory or disk space. And don't forget simple human configuration errors. The key insight here is that most of your problems will fall into one of these buckets. That makes them predictable, and more importantly, it makes them preventable. The cost of constantly fighting these fires, it's just staggering. That same Fivetran report found that 53%, more than half of all data engineering time, is spent just firefighting existing pipelines. Just think about that opportunity cost for a minute. That's time that is not being spent building new products or generating new insights for the business. So that's the big question, right? The cost of being reactive is crystal clear. So how do we break the cycle? How do we shift our focus from just debugging broken pipelines to actually engineering them so they don't break, or at least don't break catastrophically in the first place? And the answer?
It's all about building resilient systems. This means a fundamental shift in our mindset. We have to start engineering for reliability from day one, not just for basic function. Look, a pipeline that works perfectly on the first day, but is so brittle and fragile that it breaks a week later, that's not a good pipeline.
So what does that actually look like in practice? Well, first up, idempotent operations. It's a fancy word, but it just means you can run the same job multiple times and always get the same result without creating a mess of duplicates. Then, schema validation. Think of it like a bouncer at the door of your pipeline, checking IDs and rejecting any data that doesn't match the format you expect. Automated retries are great for handling temporary glitches like a network hiccup. And finally, my personal favorite, the dead letter queue. Instead of letting one single bad record crash the entire process, the pipeline smartly shunts it aside for you to inspect later, which allows all the good data to keep on flowing.
And really, that's the whole goal here. A perfect, failure-proof pipeline, it's a myth. It doesn't exist. The real goal is to build pipelines that fail gracefully. They anticipate problems, they give you clear, understandable error messages, and whenever possible, they recover all on their own without waking you up at 3 a.m.
Which brings us to the last and maybe the most important question you can ask yourself about your own systems. Is your monitoring simply asking, did the job run? Or is it asking, is the data right?
And that right there, that's the big shift. We need to move from simple infrastructure monitoring, which only tells us about crashes, to behavioral monitoring. This means tracking the actual patterns, distributions, and shapes of our data over time. That's the game changer, moving from just watching the machine to watching the data itself. That is how you catch those silent failures, and it's how you go from reacting to problems to preventing them before your stakeholders even know they exist.